sequences. Problem numbers 41, 44, and 59. So, problem 41. Find the 10th term, find the value of the indicated term, 5, 30, 180. So to do this, we need to figure out what R is. R is 30 divided by 5, which is 6. Now just to check, 30 times 6 is indeed 180. The initial term is indeed 5, so it's 5 times 6 to the, don't forget, it's got to be the n minus 1. So when you're finding the 10th term, which is a sub 10, it's 5 times 6 to the 10 minus 1, aka 5 times 6 to the 9th. So a sub 10, simply put, is, wait for it, 50,388,480. Commas are helpful in that case. Yeah, that's right. It gets rather large rather quick because we're multiplying by 6 each time. So, a sub 1 equals 5. A sub 3 is 45/4. Find an 8th term. That is, find the value of the indicated term. Now, this is a little bit trickier. So, I'm going to go ahead and use my crutch. That is my table. Knowing that n equals 1 is 5, n equals 2, and then n equals 3, which is 45/4. There's a couple different ways to do this, but one thing you have to recognize is what? Well, to go from 1 to 3, I had to multiply by something. Now, we have to know that this is geometric, and it's given this is geometric, which means I'm multiplying by r to get to here, and then I'm multiplying by the same r to get to here. What that really means in the grand scheme of things is that 5, my initial value, that is this first one here, times r twice, aka r squared, is 45/4. Great, you say. What does that mean? Well, it means r squared is, divide both sides by 5, what do you get? 45 over 20? Nah. You get 45 over 4 times 5. Why is that helpful? Because that's the same as saying 9/4. 45 divided by 5, right? 45 divided by 5, right? Why is that helpful? Because when I take the square root, I'm going to get 3/2. Now, before you get too satisfied with yourself, don't forget you actually have to find the 8th term. So what you need to do is write a sub n, and we knew that this was 5 times, well now we know that this is 3/2, still to the n minus 1. So if I want the 8th term, a sub 8, like a sideways infinity, right? 5 times 3/2 to the 8 minus 1, which is 5 times 3/2 to the 7th. What is that? Well, here's where the fun begins. You ready? 85.4297 is what I got. 4297. You probably don't need to go that many decimal places, but hey, didn't hurt, did it? 59. Find the indicated partial sum. Okay, so the indicated partial sum would be what? Well, from 0 to 20. How many terms is that? So I'm going from 0 all the way to 20 is, now this is where you have to think way back. 20 minus 0 is 20. But you have to add 1 because you're actually starting at 0. Now if you use your fingers carefully, you'll cover up with the fact that 0 through 20 is actually 21 terms. So if you want to think about your sum formula, you're actually finding s sub 21, which means you still need we still need the first term. Well, the first term is at 0. That means I need to plug 0 into here. But wait, you see, if I plug 0 into here, this goes away. So what's my first term? When n equals 0, that is a sub 0, that's equal to 12. So my first term is 12 times 1 minus, well, let's uncover this. What am I multiplying by each time? 6/5. 1 minus 6/5. It's a little bit more than 1, right? And, what did I forget? I had forgot to raise it to the 21st power. That's kind of important. Please bear in mind that 21st power is inside of the parentheses. Otherwise, you'll get an embarrassingly small number, which is wrong. And then 1 minus 6/5. Now, not to bore you with the details, but if you actually run the numbers, I'm not going to do it out, but you get 2700.31 or thereabouts. And that, as they say, is that.